Dear students, in this lesson we'll study the electric current and the cells. We have known previously that the electricity play an important role in our daily life. In this lesson we will identify some sources and types of the electric current and the methods of connecting the cells in the electric circuits. First, the electric current is generated in two methods. Number one, change the chemical energy into electric energy in electrochemical cells. Electrochemical cells. The electrochemical cells is the batteries. And the electrochemical cells or the batteries produce direct current. So, the first method to generate the electric current is by the electrochemical cells or the batteries that produce the direct current. Number two, changing the mechanical energy into electric energy by the electric generator or dynamo. So, number two, changing the mechanical into electric by electrogenerator like the dynamo. And the dynamo or the electric generator produce alternating current. So we can summarize the ways or the methods of producing the electric current as we have two devices, electrochemical cell or the batteries that use the chemical to change it into electric to produce direct current. And we have generator or electric generator like the dynamo that use mechanical and they change it into electric. It's kind of producing alternating current. And the types of the electric current or the electric current can be classified according to the direction and the intensity in the two ways. So we can compare between the two types of the electric current, the direct and the alternating, by the direction and sources and the intensity of each of them. Number one, we have the direct DC. What is the DC? It by the D direct and current C. Direct current DC. It's the constant intensity. So the intensity is constant in the DC and variable in the AC. What is the AC? It's alternating current. The direction of the direct DC is flow in one direction. It's flow in one direction from the pole of the battery, then through the circuit toward the other pole of the battery. So it flow through the circuit in one direction. And the alternating current AC, it flow in opposite direction. It flow in opposite direction like the crusts and troughs. And this is the shape of the constant. It's constant to the direction. So this is the direction of each of them. Then we have the source. The source of producing the direct current by the electrochemical cells such as the simple cells and the dry cells. And the source to produce the alternating current is the electric generator dynamo. Then we have the direction of the transfers. The DC can transmit or transferred over short distance during the or by the electric wires. And the direction or the distance of the alternating, it can transferred over short and long distance. It could be short or long distance to transfer through the wires. The usage of each of them, starting with DC. What is a DC? Remember, the DC is direct current. Operating some electric machines such as the torches and the other things that need a small amount of charges or a small amount of the current. And the alternating using or usage in the lighting houses, streets, operation, the electric, the like the houses and all the devices contain. And the conversion of the DC, it can convert it into alternating, and the AC, it can into the direct, it can change into direct. And if we have several of the electric cells that's known by the batteries, or we have several batteries, we can make two method of connection. We have series connection and parallel connection. What is the difference between them? The series connection, it's kind of connection that the negative pole is connected to the positive pole of the, and so on. The connection of the battery in parallels, so the positive poles are connected together while the negative poles are connected together. So this is the two methods of the connection of the batteries. We have series and we have parallel. So the first cell, the negative first cell connect to the positive second cell, and the negative connect to the positive, and negative connect to the positive, and so on, with the one rod or one wire. Okay, the four batteries connected in the same wire. And the parallel connection, the first cell is connected, is connected to the positive. The positive is connected with positive. The positive of the first cell is connected to the positive with the second cell, connected with the positive in the third cell, and so on. So we have several wires or the branching rods. Okay, then we have the electromotive force. How we can calculate the electromotive force? Remember that? Yes, by the voltmeter. So electromotive force is the voltage of the cells, when we connect the voltmeter in parallel with them. So in open circuit, of course. The sum of the electromotive force of all the cells. If we have four cells, as we know, we have four cells, so the electromotive force of the total, the cells, it's equal the E1, E2, E3, E4, the sum of them considered as the electromotive force when the connection is series. So when the connection is series, we can calculate the electromotive force of the circuit as a sum of them, the summation of all the cells together. And when the connection is parallel, the cells have the same electromotive force of the one cell. So if the first cell is 1.5 and the second 1.5 and the third 1.5 and the connection is parallel, so the all summation of the electromotive force of the whole circuit is 1.5. Again, so if the cells have the same electromotive force 1.5, so the sum of the connection of the cells inside the parallel connection equal 1.5. It's equal to each other. In this example, we have different forms of the connection in the three circuits. The first circuit A, we have connection in series. So all the cells connected in series with the voltmeter. So the electromotive force of the three of them is the summation of each of them to the other. So E battery, the electromotive force for the battery equals the 3 batteries times 1.5. The 3 batteries times 1.5. So it's 4.5 volt. In figure number B, or the circuit number B, we have two connected in parallel, and the two connected in series with the third one. So if we have three cells, each of them 1.5. The first two connected in parallel to each other, and the two of the cells connected in series with the third one. Okay, so the electromotive force for the battery equal the two connected in parallel, it's equal to the one of them. So the two, 1.5 and 1.5 equals, finally it's equal 1.5 of them, all of them. Connected with series, so 1.5 for the two plus 1.5 for the third. So it's 1.5 for the two of the parallel plus 1.5 connected in series equal 3 volt. The third one we have in the figure C, we have two connected in parallel, so it's 1.5 for all of them, and the other connected in parallel, so it's 1.5 for all of them. So 1.5 for the two of them and 1.5 for the other two. And the summation when the 1.5 is parallel to each other and series to the other two. So this is the series for the other. The two is series to the other. So the summation of them 1.5 for the first parallel and 1.5 for the second parallel in the series connection equals 3 volt.